Good afternoon all. My name is Sunny Arora, Assistant Professor with Ajay Kumar Garg College of Engineering, Ghaziabad. So today I'm going to teach you basic concepts and hierarchy of memory and the semiconductor RAM memories. So that will be the topic for today. Basically, starting with what is main memory. Main memory is basically used for the central storage unit of computer system. It is relatively large and used to store programs and data during computer operations. As we understand, basically main memory stores our programs and the data. The principal technology used for main memory is based on semiconductor integrated circuits. Integrated circuits, RAM chips, are available in two modes. The first is static and the other one is dynamic. Static RAM and dynamic RAM. So now we understand what is static RAM. Static RAM consists essentially of internal flip-flops that stores the binary information. The stored information remains valid as well as power is applied to the unit. Dynamic RAM. Now we understand what is dynamic RAM. Dynamic RAM is basically consists of our capacitors that stores the electronic charge. That are basically the capacitors are provided inside the chip by MOS transistors. The stored charge on the capacitors tend to discharge with time, and capacitors must be periodically recharged by refreshing the dynamic memory. So we should understand the dynamic memory basically uses the capacitors that stores the charge, and that there is a leakage of the charge over the period of time. That is why the refreshing of the dynamic RAM is required, and refreshing is done by cycling through the words every few milliseconds to restore the decay charge. That is why we say that refreshing of the dynamic RAM is required, because there is a decay of the charge. So we have to understand the dynamic RAM is slower. What makes it slower? It basically this decay of the charge, and refreshing for that charge requires it to refreshing. So that refreshing basically is needed in the dynamic RAM, that makes it not to decay the charge. Now I show here the static RAM and dynamic RAM. The first parameter for the comparison of these memories is construction. SRAM, that is static RAM, is made up of transistors, and dynamic RAM, as I just explained, it is made up of capacitors. Speed, second parameter. The speed of the static RAM is faster than the dynamic RAM. Obviously, since dynamic RAM needs refreshing, so that makes it slower. The next one is cost. Static RAM is expensive, whereas the dynamic RAM is cheaper. The fourth one is power consumption. Static RAM consumes more power than the dynamic RAM. Dynamic RAM consumes less power than the static RAM. Storage capacity. Storage capacity of static RAM is lesser than the dynamic RAM. Therefore, it is low in case of static RAM and high in case of dynamic RAM. Next, density. That means how many bits we can store in. It is same as your storage capacity. Basically, in static RAM, it is low, and in dynamic RAM, the density is high. Static RAM is basically used in cache memory, and dynamic RAM is used in main memory. Next is ROM, that is read-only memory. Most of the main memory in general purpose computer is made up of RAM integrated circuit chips, but a portion of main memory may be constructed with ROM chips. RAM is used for storing the bulk of programs and data that are subject to change. That is the point to understand. The data that we store in the RAM is our programs and data, and that is subject to change, which can be changed. But in the ROM, the data is permanently resident, that cannot be changed. Among other things, the ROM portion of the main memory is needed for storing an initial program called a Bootstrap Loader. Now we should understand what is a Bootstrap Loader and why is it stored in ROM. Why, as I've just explained, that ROM needs to store a permanently resident data. So this point must be cleared from here, that Bootstrap Loader is a permanent data that is stored in the ROM. It is a permanent software basically that is stored in the ROM. Now we will come to the Bootstrap Loader. We should understand what is this loader and what is the purpose of this and why do we store this Bootstrap Loader in ROM. The Bootstrap Loader is a program whose function is to start the computer software operating system when power is turned on. Since RAM is volatile, its content is destroyed when the power is turned off. The content of ROM remains unchanged after the power is turned off and on again. Again, this is important point to understand. Bootstrap Loader loads the operating system in the RAM. This is a program, or you can say this program is stored in the ROM, and that initiates the loading of the operating system in the RAM. And the ROM content remains unchanged even if the power supply is not there. But the RAM content will be flushed off or will not be there if the power is off. Therefore, the Bootstrap Loader is permanently stored in the ROM. Now the startup. The startup of computer consists of turning the power on and starting the execution of the initial program. When the power is turned on, the hardware of the computer sets the program counter to the first address of the Bootstrap Loader. So here we will come to the point that what is program counter, as our text is using program counter. So program counter basically loads the address. It's a register which stores the address of the first instruction of the Bootstrap Loader. Since Bootstrap Loader is a program and its first address will be stored in the program counter. So when we turn on the computer, the microprocessor will see the content of the program counter, and program counter will bring microprocessor to the first address of the instruction of the Bootstrap Loader. Then Bootstrap Loader will start loading the operating system from that address onwards. The Bootstrap Loader loads a portion of the operating system from the disk to the main memory, and control is then transferred to the operating system, which prepares the computer for general use. Next, I will discuss about the RAM and ROM chips. RAM and ROM chips are available. RAM and ROM chips are available in variety of sizes. If the memory needed for the computer is larger than the capacity of one chip, it is necessary to combine a number of chips to form the required memory size. For example, you need the memory size larger than the memory size that is available to you. Then what should we do? We basically will combine a number of chips to form that required memory size. So a RAM chip is better suited for the communication with CPU if it has one or more control inputs that select the chip only when it's needed. So here we should understand this point. If we have multiple RAM chips available in the system, therefore we need to select one of the chip out of those present multiple chips. A RAM chip is therefore better suited for the communication of CPU since it has more control inputs. These control inputs are meant for selecting the required chip out of those all present chips in the system. Another common feature is bidirectional data bus. Now this data bus, what is this data bus? That carries your data. It may carry that data from memory to the bus, or bus to the memory, or it may carry the data from registers to the memory and vice versa. So that is another common feature, that a bidirectional data bus that allows the transfer of data, right? As I just explained, this bus will carry the data. A bidirectional bus can be constructed with 3-state buffers. We have already studied in the previous chapters that how can we construct a bidirectional bus. We have studied 2 topics in that. The first one was by using tri-state buffer that has control inputs, and also we have also studied using multiplexers. So from there you can understand how do we construct this bidirectional bus that is used for the transfer of the data. Now I explain the RAM chip. As we can see, RAM chip has CS1, CS2 bar, read, write and AD7, these pins available over this chip. So the size of this memory is 128 into 8. And if you see this bus over here, this is bidirectional. You see that? This is bidirectional. And this 128 and 8. Now we have to understand now we should understand how this address lines are of 7 bits, because the RAM size is of 128 into 8. That means this is the size of this chip, which consists of 1 word data. Okay, so 7-bit address is from this 128. So basically 2 power 7 makes 128. Now we see the function table of this chip. This table is basically, if you see that, the function table specify the operation of this RAM chip. The unit is in operation when CS1 is equals to 1 and CS2 is equals to 0. Since we can see it from here, otherwise this is all in inhibit state. You can read the data or you can write the data when we have these inputs 1 0 1 0. Okay, otherwise this will remain in the inhibit state. Okay, inhibit means it is in the high impedance. As we understand from the concept of tri-state buffer that there is a high impedance state, that means it is in the open circuit. And if you give write signal value 1, then you can write the data using the bidirectional bus to this chip. Similarly, if we give 1 input over the read signal, then we can read the data from this chip over the bus. That means we can transfer that data which is required to be read over the bidirectional bus. This is what is being explained over here. The unit is in operation only when CS1 is equals to 1 and CS2 is equals to 0. If the chip select inputs are not enabled, or if they are enabled but read and write inputs are not enabled, the memory is inhibited. As we have seen in the previous slide, if they are not enabled or if they are enabled but read and write are not, if the chips are selected, if the chip select inputs are not enabled or if they are enabled, but the read or write inputs are not enabled, the memory is inhibited and its data bus is in high impedance state. So when CS is equals to 1 and CS2 is equals to 0, the memory can be placed in read and write mode. This is quite important. When they are like when CS1 is equals to 1 and CS2 is equals to 0, the memory can be placed in read or write mode. That is what is shown here. When CS1 is equals to 1 and CS2 is 0, and then it can be placed in either read or either write mode. Read or write mode. When the write input is enabled, the memory stores a byte from the data bus into a location specified the address input lines. And when the read input is enabled, the content of the selected byte is placed into the data bus. Read-write signals control the memory operation as well as bus buffers associated with the bidirectional data bus. Why are these buffers required here? Because what data is to be stored in the RAM or what data is to be retrieved from the RAM stores in the bus buffer. Now we see the ROM chip. We have two pins over here, chip select 1 and chip select 2. This is chip select 1 and chip select 2 bar. And we must see that this is a unidirectional bus over here because it is ROM that only is used to read the data. And if you see the size of this chip, it is 512 into 8. Okay, it is the RAM chip was of 128 into 8 and here it is of 512 into 8. And because it is 512, so the number of bits which will be used to store the address will be 9 bit. Since 512 is equals to 2 power 9 and 9 bits will be used to take the address in the ROM chip. One more important point about ROM is this second point. For the same size chip, it is possible to have more bits of ROM than RAM because internal binary cells in the ROM occupy less space than in RAM. So this is quite important because the internal binary cells of the ROM occupy less space in RAM. For this reason, the diagram specify 512 byte in ROM and 128 bytes in RAM. See this is 512 in case of ROM. And from here, see this, it is of 128 size of one word. This 8 is basically representing size of the word, that is 8 bits. Now next is memory hierarchy. This triangular shape figure is representing the memory hierarchy. We have few levels over this, like from level 0 to level 5. Over the level 0, we have registers. Registers are basically we have some general purpose registers and special purpose registers. And it may also varies from one processor to another processor. Here on level 0, we have registers. On the next level, we have cache memory, which are made up of static RAMs, as I have explained before. And then we have next level 2 that stores, that is for main memory, and that is made up of dynamic RAMs. And then further we have magnetic disk, optical disk, and magnetic tapes. From here we should understand one point. If we go from bottom to top, the cost will increase. The cost will increase. And if we go from top to bottom, we should understand the access time and the capacity will increase. Or you can also say the search time will increase if we go from top to bottom. Also, the storage capacity will increase. I can give you a general example about this. For example, if you want to search a person, in a country, if you want to search a person in a state, or suppose you want to search a person in your society. Okay, so now you can understand, if you are searching a person in a society, it will take less time because the society has lesser space than the state, and the state has lesser space or area than country, right? So if you have to search a person in a country, then it will take long time. Similarly here, if you have to search some data in the disk, like magnetic disk, optical disk, it will take more time than the main memory and cache. Therefore, registers which has the smallest area, smallest space, the data searching will be easier and it will take less time in the register. And this will grow from top to bottom. Thank you. That is it. So in the next class, I will explain you how do we get a required memory size. Using some questions, using some examples, we will be learning how do we get the memory size required at a time. Thank you.